Okay, so good afternoon, guys. So we are going to start a new chapter in fluid mechanics, that is impact of jet. And in this we are going to study the first topic, that is impact of jet on a static flat plate. So there can be various conditions of impact of jet on a flat plate. The plate can be flat, the plate can be inclined, plate can be curved as well. So there are many conditions. But for the time being, we are considering that the impact of jet is on a static flat plate. So moving on to next, consider a horizontal jet of water impacting a flat static plate as shown in the figure. Let V is equal to velocity of jet and D is the diameter of jet which is falling on the static plate. So before that, we have to make certain assumptions before we derive expression of force applied by the jet on the plate. So what are the assumptions? Let's see. First one is there is no loss of energy in the process. During this entire process, there is no loss of energy. Second one is the plate is frictionless. It means that whatever the velocity is impacting the plate, and after the impact, the jet is leaving the plate with the same velocity v. Third one is velocity is uniform throughout. As you can see that the incoming velocity is v, and after striking the velocity remains the same v. The fourth assumption is that the pressure is constant, that is atmospheric pressure. So moving on to next, applying impulse momentum theorem. We know that F is equal to delta mv, that is change in momentum. So we know that change in momentum is mass into change in velocity. So mass not going to change, what will change is velocity. So mass of the liquid in this case is rho av, and change in velocity is v1 minus v2. M is equal to rho av. So where does this M is equal to rho av come from? Let's revise it, as we know that we have done it before also. But still look at this. So here we can write it as, we know that M is equal to volume into density. Volume into density. Now volume can be written as volume per second. Actually it is volume per second. Volume per second into density of liquid. So volume per second is nothing but Q, that is discharge. We know that discharge Q is equal to area into velocity into density. This is mass. So this mass is nothing but this, M is equal to rho av, density of liquid into area into velocity of jet. So initial velocity is v and final velocity is 0. So here we can write is a v1 as v. v1 can be written as v. It is initial velocity, and v2 is 0 because after the impact the velocity becomes 0 in that direction. So after that the force is calculated as F is equal to rho av square. So this is it.